In this video, I'm going to have a Python program fit some data to a straight line. And I've done that in a previous video, but the difference this time is that I have different data, and for that different data, I would like to set the intercept, the constant, to 0 and not have that as one of the fit parameters. So the code for this can be found at the URL seen here. We just want to briefly look at the previous one. I was doing a linear regression for some heart data. And here originally 48 is how I was doing the actual fitting. The linear regression was NP was the numpy, and I was using polyfit. And then as I was attempting to do or looking up how to do what I want to do now, which was set the constant to 0, I was reading that polyfit is like the old way of doing it, and you should be using the sort of the polynomial and dot fit. You should be taking that approach. And so I made this replacement for 48. I used polynomial fit, and I have my x's were in that case speeds of exercising, and my y's were heart speed, and it was a polynomial of degree 1, so a constant and a linear term. And then I could take the fit. So up here in polyfit, it was spitting out sort of these two individual pieces. Here it was giving me this thing I was calling the fit. And then I was extracting from that the intercept and the slope by just evaluating that thing at 0 to get the intercept, and taking the difference between it evaluated at 1 and 2 to get the slope, because it was linear, so that gives me the slope. And then I was also just printing it. And in this version, there's my fit. And here's those two prints. And I just want to show that the actual one I want is the second one, which is converted. So there was something, weird going on in terms of scaling and domains and windows, and just something I'm going to have to deal with going over to Hubble, because I am going to have to take this fit approach, or I'm going to take this fit approach in Hubble. And so I'm going to run into this, but I'm going to sort of get rid of it. Okay, so back to the matter at hand. Okay, so again, here it is if you want it. I'm using numpy, I'm using matplotlib, and then at the end, I also throw in an OS, so that I'm going to save my plot as a PDF, and I want it to be saved in the same location as my code. So I was using the OS to set the directory. So here I am. Let me just run and let me stop the heart one. This is sort of modal, so you have to sort of let that close that so the program can stop and then start the next one. So now I'm in Hubble, and here's the data. And this time I'm fitting with the no constant, no intercept, or the intercept set to 0. And here's the same data over in Excel. And here I just fit it to the data to a straight line. And here I used Excel. You can format that trend line and set its intercept to 0. And so you can see we're getting the same values that Excel got, the 423.94, 423.94. Okay. So let me close that before I forget that it's open. Okay, so we need matplotlib, we need numpy. Here are the data. I just sort of hard-coded in the distance and the velocities. This is Hubble's data from astronomy. So here's making a plot, figuring out how far things were from, I guess, the Earth, and the velocity at which they were moving either toward or away from the Earth, and then making a plot of that. It has something to do with the expansion of the universe. Okay. This here was making the background, the plot area. This is light blue. Actually, now it's a light yellow. And adding a little grid. And then here I am making the scatter graph. So my x's are the distance, my y's are the velocities. This has to do, S was something to do with how large the dots were. Alpha is if you can see through them, and this is a dark or medium blue, and then there was an edge color, which was a dark blue. Okay, so that was the points. And then here's the actual fitting. So I'm using numplot, which I saved, brought in as NP. I'm using polynomial.fit. And so that does the fitting. I give it my x's, and which were the distances, and my y's, which were the velocity. Here is how I am doing instead of saying degree equals 1, which if I have up here commented out, if I have degree equals 1, that's going to give me all of the degrees of a polynomial up to 1, so 0 and 1, so a constant and a linear term. But if I put it in as a list, then I can just list the powers that I want. So I can just say I want a list of just 1, so no constant. If I wanted to have a constant and a square term, but no linear, I could say like 0, 2, I believe. So, but this is my way of getting, taking the constant out of the fit. So again, my x's, my y's, my degree, but now my degree as a list of powers rather than, if it's not a list of powers, it's all the powers up to and including the degree. But here I'm giving it a list with just a 1 in it. So it's going to skip the constant. Here's the thing that made me skip over this weird scaling thing. So domain equal open close square bracket. And then there was a bunch of other things that I found in one example, so I put them all in. And don't know if I need them. The symbol X must be that when it spits out the fit, it's with an X variable. So I can, presumably I can change the variable. But the important one to me was the domain, because it was doing, if you remember back over here on the linear regression, now let me go back here and run this one again. So I was getting these sort of two sort of fits, and the one I want needs to be converted. And that wasn't too big of a problem here in this heart data, but over here in Hubble, I wanted to set a constant equal to 0, and I wanted to set a constant equal to 0 for the actual data that I was interested in, and not for some weird other scale domain, whatever the hell they're doing. So I needed to not do this, whatever, for whatever reason they're doing this domain window scale thing. I didn't want them doing that, because I wanted, when I said the constant was 0, I wanted the constant to be 0 for the actual data that I'm interested in. Okay, so this and this sort of were a team. The degree 1 and the domain open and close square bracket work together to get, for the data as it is, no weird scaling domain, to have a linear term but no constant term. Okay. And just I extracted the slope. I can sort of, this is sort of comes out sort of as an equation. So if I just, well, that's the hard data. So let me not be too confusing and rerun the Hubble. And so it comes up as a as an equation here. So I can, I can just sort of slap up the equation, but I wanted to extract the slope because I wanted to say round it before I displayed it with all those crazy number of decimal places. So I did want to still extract the slope. But you see here, I'm doing the fit and the convert, and they're the same now. And that sameness was coming from this domain. Without the domain, without me saying anything or me saying the domain was none, I was getting these were different. And then when I was getting the one I actually wanted, it had a constant. So I needed these two to set the constant to 0. I needed these two working as a team. All right. Created a set of x's, created a set of x's and y's, and plotted them. So this is my fit line. And here I am creating the fit line to display on my equation or on my plot. And here's me actually putting it on my plot. And here's me titling my graph and giving an X label and a Y label. And here's me changing the directory to the current working directory or the directory the Python's in, so that when I save the Hubble PDF, it's in the folder with the with the PY. So the PDF's in the same folder as the PY. And then I'm showing it. So that's bringing up that sort of little modal pop-up window that's showing me the plot. Okay, that's what I wanted to show you. To play this fitting game now, what they're claiming, they seem to be claiming now to be the proper way with polynomial.fit. And also I wanted to set the constant equal to 0, and that was these two together, setting the degree equal to a list with just a 1 in it, so only a linear term, and setting the domain equal to 0 so that it's actually fitting the data without doing it in some bizarre scaled version of fitting the data, but fitting the data where I want it fit or how I want it fit the actual data, so that the constant is 0, sort of in the overall desired result. Okay, so that's what I wanted to show you. Thanks for your attention.